Welcome to the Bentley Systems training course where you will learn how to model surfaces in the STAAD.Pro Physical Modeler. In this particular video, we're going to show you how to model loads on your surfaces and regions. And before we get started with that workflow, let's go ahead and review some of the information that the model already contains. So in the ribbon toolbar, select the Spreadsheet tab and then the Load Cases icon. This will show you all the load cases that are currently in your model. For my particular model, I've already defined my dead load case and my live load case. In addition to that, if I scroll a little over, what you're going to notice is that the self weight has been already assigned to my particular model, which will include the surfaces. Now, to calculate the self weight within the program for surfaces, the program will use the material properties or density of material that's assigned, and then also the thickness of each surface. In addition to that, for this particular model, you're going to see that I also created a load group to represent my wind load. We'll get to that load case a little later in this video. So let's go ahead and start by creating a uniform pressure or area load over an entire surface or region. So what we're going to do is we're going to make our selection first. Let's go to the Data tab in the ribbon toolbar, and we're going to click on our Groups icon. Now, right now, we're going to go ahead and start working on our floor slab. So I'm going to select that group and then click the Select option. Once I do that, I can go to the Surface tab in the ribbon toolbar, and I can see all of my loading tools that are available. Here, I'm going to select a uniform pressure load. I'm going to enter either a load case or load group. I'm going to work on the live load case, and the load cases and load groups would need to be predefined once you get to this point. Next, I'm going to enter a pressure. I'm going to enter that at negative 0.05 kips per square foot, and the direction will be in the global Y direction. Again, the negative sign indicates that this is a downward acting force. Once we're done, let's go ahead and click OK. Now that I've assigned a uniform pressure to my surfaces in my model, I'm also going to assign a uniform pressure to the region I created at the upper roof level. So what I'm going to do is I'm going to just go ahead and just select my entire model. This will select everything including the region. If I apply a load specifically using the Region tab of the ribbon toolbar, it won't apply it to anything else, just whatever regions I currently have selected. So let's go ahead and click on that Region tab in the ribbon toolbar and tell the program we want to assign a uniform pressure. Again, I'm going to select the load case and I'm going to enter the pressure value and the direction. Once I'm happy with the information, I can go ahead and click OK. Now for this particular exercise, we specified a uniform pressure for the roof surface and a uniform pressure for the region that is within the roof surface. Both of these loads were applied to the same load case. When the loading information is transferred to the STAAD.Pro Analytical Modeler, it is important to understand that these loads will be added together so that the total load for the area of the slab that represents the region will be the main area plus the region, which will be 0.7 kips per square foot for this particular example. Now let's go ahead and take a look at how to model variable loads on surfaces. So let's go ahead and clean up our display. To do that, we're going to reset our visualization options, and we're going to select the wall areas that basically represent our elevator system. So let me go ahead and say, select the Data tab in the ribbon toolbar, and then the Groups icon. And here, I'm going to tell the program. And here, I'm going to tell the program I want to select my walls. And let's go ahead and close out of there. Now at this point, I want to isolate this particular view. So I'm going to say View, Selected Objects Only. Now for these particular walls, what I'd like to do is I would like to apply it to the local coordinate system. And it might be helpful to turn my local axis system on while performing this exercise. So Still in the View tab in the ribbon toolbar, I'm going to tell the program I want to turn on the local axis system. And what we're going to notice, let's go ahead and spin this around to make it a little easier. What we're going to notice is that the local z-axis is pointing towards the inside of the structure for all of these selected surfaces. This confirms that this would be a good method for me to assign my loads. Now let's go ahead and work on one of the surfaces. Let's go ahead and select this surface over here. And what I want to do is I want to assign a wind load to this particular surface that is variable in nature. I've selected the surface I am working on. I'm going to go to the Surface tab in the ribbon toolbar, and I'm going to tell the program I'm working on a variable pressure. I'm going to select the load case or load group. Here I'm going to select the wind load. Next, I'm going to enter the direction, and the local z-axis works for me. Variation along the element. Let's take a look here. So my y local axis system is pointing up and down in the plane of this particular wall. So I'm going to go with variation along the local y axis. So I'm going to enter pressure 1 and pressure 2. Pressure 1 will be basically at the minimum local y-axis area, and then pressure 2 will be at the maximum local y-axis area. My local y-axis is pointing down, so pressure 1 would be at the top of this element, pressure 2 is at the bottom. Let's go ahead and enter my values here. I'm going to enter 0.02 kips per square foot for pressure 1, and pressure 2, I'm going to enter 0.04 kips per square foot. Once I'm done, let's go ahead and click OK, and I should be able to see that pressure appear. Now, if you accidentally switched pressure 1 and pressure 2, you can just simply undo and redo the command in the proper order. Let's go ahead and repeat that process for the bottom 2 levels. Now for this particular model, I'm going to say I am finished applying my wind loads to this particular wall. I'm going to go ahead and click on the View tab in the ribbon toolbar and tell the program I want to view selected objects only, or basically I want to turn my entire model back on. Again, I'm going to clean up my display, and then I'd like to finish by selecting my entire model.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.